Hello and welcome back to another video. In this problem we're asked to let f of x equal brackets of cosine of x from negative pi to x to pi. So we're asked to sketch the graph of f. First we have to understand what these brackets mean. And that refers to the greatest integer function, which states that for any value of cosine of x, this function is equal to the greatest integer less than or equal to cosine of x at that particular x value, right? So if cosine at a certain value is equal to 0.5, brackets of 0.5 is 0, because that's the greatest integer that's less than or equal to 0.5. So sketch the graph of f. So we're doing this from pi to negative pi. And first let's graph cosine. So cosine looks a little bit like this, right? And this function is taking the greatest integer that is less than or equal. So at 1, the integer that is equal to 1, the greatest integer that is less than or equal to 1 is exactly it itself, 1. In between this point and this point, we have values of cosine that are between 0 and 1. Therefore, the greatest integer that is less than or equal to them is right here, it's 0. So we have open circle. All of these are 0, and then the function is actually at 0. And again, the greatest integer that is less than or equal to 0 is 0. And then here we have negative values. So the greatest integer that's less than or equal to, let's say, this point, or this point, or this point, are all negative 1. And then we reach a point of negative 1 here, and so that fills in right there. Similar thing here, we have positive values between 0 and 1, so they have a value in this function of 0, because that's the greatest integer that's less than or equal to them. We hit 0, we hit negative 1, and in between here, we have all these negative values. Now we erase the original cosine function, and we just get this as our function. So now we're asked to evaluate each limit if it exists. First, we have the limit as x approaches 0 of f of x. So we can see that as we approach from the left and the right, even though the actual value of the function is at 1, as we get closer and closer to 0, we have a value of 0 as we approach. From the left and the right, they're both equal. Therefore, the limit is equal to 0. In 2, we have the limit as x approaches pi over 2 from the left. This is pi over 2. We're approaching from the left, which means we're approaching from a value of 0. In 3, it's the limit as x approaches pi over 2 from the right. So we're approaching from values greater than pi over 2, so we're coming this way towards this point at a value of negative 1. And therefore, we can say that since from the left and the right, they don't match each other, right? 0 does not equal negative 1. If we look graphically, they're not approaching a similar point from both directions. We can say that the limit as x approaches pi over 2 of this function, dne, does not exist. C, we're asked for what values of a does the limit exist? Well, we can see that at points where the function is jumping in value, the function does not exist. And we're only looking at the values of x between negative pi and pi. So for what values of a does this function exist? Well, if a is greater than pi or a is less than pi, just by definition the function doesn't exist, right? Because we're told that we're limiting the function to this range. So what is the value of this function at 3 pi? Well, the cosine function within the greatest integer function, this has a value at 3 pi, but it's not f of x, because f of x is limited here, so these values. And then we're also told, or we can see, that at this point and at this point, we have pi over 2 and negative pi over 2. So these are the values for which a does not exist, which I guess is the opposite of what we're asking, so we can actually respond in the method that they want us to. So for what does it exist, if we go from negative pi to negative pi over 2, from negative pi over 2 to pi over 2, and from pi over 2 to pi. At these values and no others, the limit as x approaches a of f of x exists.